Hello and welcome back to the Building HVAC Science Podcast. You know, it's our goal here to help the professions of HVAC and building performance, home performance work better together, understand each other, and with the ultimate goal of making customers happy in the homes they live in and the buildings they work in. Well, this whole pursuit of these topics in my life has led me down a lot of different paths, but the paths all congregate around energy. So, in today's episode, Eric and I will be talking with Chris and Cheryl Moore, and they're the founders of Harmony Turbines, which is a wind turbine company in Lebanon, PA. And as I say in the interview, full disclosure, I'm a really small investor in their company, but they talk about some really fascinating topics. They get into the technical aspects of turbines, describing it as a modified Savonius vertical axis wind turbine with a unique helix twist. This allows it to capture wind from any direction and self-regulate the speed in high wind conditions and also start up at a low speed. Really interesting. They are actively raising funds through Start Engine, and at your discretion, this is not financial advice, but at your discretion, you may want to take a look at that. There's some great links. There's some links to their YouTube, to their website, to the Start Engine investment page, all in the show notes. So without further ado, let's get into reinventing wind power inside the world of Harmony Turbines.
Hello, everyone. Welcome back to the Building HVAC Science Podcast. Eric Kaiser here, Bill Spohn right over there. And our special guests today from Harmony Turbines, we have Chris and Cheryl Moore. And today we're talking about wind turbines. Welcome.
Thank you.
Thank you. Thanks for having us.
You're welcome. Just like full disclosure, like people always say, I am an investor with Harmony Wind Turbines, their company. And why don't we start on that note? How did you get this, what do you call it, Start Engine? How did you get involved with that?
The project, if I'm allowed to go back a little bit further than just Start Engine, it began in my basement, as all good projects should, and started as just me trying to do something to help make the world a better place. I had this idea for what I thought would be a really, really good wind turbine that could perform in a lot lower wind conditions than other ones out there. I hate the propeller turbines. I think they're absolutely atrocious. They're noisy. They're terrible. And I'm like, there's got to be a better way. So I won't get into the nitty gritty of all the work that went on in my basement, but I very quickly came to the realization that I can't do this from my basement. It's just not going to work to be able to launch something that's as complex as Harmony. So I began looking at, okay, how can an average Joe do this? I'm doing this in my spare time on the weekends and in the evenings, and I just don't have enough money to actually get this to take off. You just don't have enough when you're in your basement and on the weekends. So I looked at Kickstarter. I looked at Indiegogo, and my wife and I chatted about, okay, well, could we sell little miniature desktop models to people? Would people even want to buy them? Does it make sense? Is it just ridiculous to waste 2 or 3 years of our life doing these things that really in the end aren't going to help? They're just trinkets that people would be able to buy that could then fund the larger development. So we realized at that moment that the larger development, that's what was important. The units that would be at least small residential size or something like that. So Indiegogo, Kickstarter, all that went out the window very quickly because those selling points are maybe $1,000. You can sell a product on Kickstarter or Indiegogo for $1,000, maybe $2,000. But when you're talking wind turbine numbers, you could be $5,000 to $10,000 for a quality wind turbine. And nobody's going to succeed with a Kickstarter or Indiegogo in that price range. So we're like, all right, well, what the heck is there? Lo and behold, this equity crowdfunding stuff started coming up on my Google searches. And we're like, what is equity crowdfunding? You start reading about it. You start seeing, well, there's some major players in here. You have your WeFund or Seed Invest, Start Engine, and
there's a few other ones.
Yeah, there's a few other ones. The one that's on the tip of my tongue, I can't think of it. But those were the major players in the equity crowdfunding round. We were tiny. We were an unknown entity. I had maybe, 3,000 people following me on my YouTube channel where I was doing some stuff. And you just can't jump onto one of these places like Start Engine or one of the big ones and have a successful round without the back end support of a following, of a rather large following. So we went with WeFunder as our first crowdfunding because they were very newbie friendly, I'll say. And we were definitely newbies. We were totally green. We knew nothing about this. We had to incorporate our company. I had it formed as an LLC, and very quickly, like within days, I had to close down the LLC and then file to incorporate because you're giving away shares of your company. So it was this huge learning curve of you have to have your company formed correctly to do this.
You have to have a board of directors.
Yeah. My God. It was like the necessity is the mother of invention. Well, necessity is also the driver behind doing equity crowdfunding. It's you are required to have this, and this in place before you can do it. So Harmony it went from being in my basement in my spare time and my after hours thing that I did to suddenly this very scary, like, oh my God, we've got to incorporate. We have to form a board. We have to have our
bylaws. And
there's bylaws and then the other legal formation terms and everything. So we had to legalize and formalize everything about this just so we could do one thing. And that was finally get some money to try and make this happen. So there's no guarantees here. You're doing all this stuff on a wing and a prayer, and you're like, holy cow, I hope we're doing this right. We raised $184,000 in that first raise, which we had no idea how good or bad we would do. It took 6 months to raise that money, and it was a bit of a crazy ride. We had friends and family that we had talked to about it, but that's only like a few $1,000s between our friends and our family. So a lot of it was communicating to our YouTube community and Facebook and LinkedIn and things like that really helped to spawn what we were doing and get the word out. And in 6 months, raising 184 from a company that had no real following, I think it was pretty impressive for us to be able to do that.
Yeah.
It didn't give me enough money to quit my job and just do Harmony full time, but it did allow me to get started. So we got a building, we got some used equipment from all over the States. And then we very quickly realized, okay, we're going to need a little bit more money. 180,000 doesn't go very far at all.
And for the time you did actually quit your job for a few months.
Yeah. I was able to back off from my full-time job for probably just a 6-month period or so.
Maybe. Yeah.
I took a very limited salary from Harmony and really had to crunch the numbers to make this happen. But we did another raise a year later. We did 220,000 at that point, and our following was up to maybe 10,000 followers and people that were really looking at this proof of concept and what we were doing and started showing their support. So it was at that point that I said to my wife, look, this is going to get way too crazy for me to manage this on my own. You're going to have to come on board, but we can't afford both of us in here on a $220,000 raise. We'll be out of money in 6 months or something crazy. It was the realization that we needed to do a real raise hit us very quickly.
Well, it was the idea of go big or go home. Like, if we're going to try it, we got to do it right. At least try to do it right.
Yeah.
So, yeah.
WeFunder was where we started, and they had a lot of their own quirks and issues, things I didn't like about how they did it. But I will say they were amazing for a first-time equity crowdfunding campaign. So anyone who's never done it before, at least back when we did it on WeFunder, they were great. But as Cheryl said, go big or go home. And that's when we decided we were going to do a raise on Start Engine. They were much larger. They had a much larger following. It seemed like they had deeper pockets. Although the odd thing is WeFunder has a larger base. They've got more users or more subscribers than Start Engine does, but Start Engine seems to have higher numbers somehow. I'm not really sure about the nuances there.
Maybe it's like the intensity factor, like it's a little bit more intense.
Or upper echelon of some kind, higher investor values and things.
When you started this, you wanted to do something for the world. And in a way, one of True Tech Tools, our company's mission is to help technicians create better environments for people. So very, very people-focused thing. So there's a lot of harmony with that. But hey, how did you come up with the name Harmony? Where did that come from?
Because everything about the invention was in harmony with the universe, in harmony with the planet, in harmony with nature. The impetus for my design was really from the yin and yang symbol. I was looking at it one day and I thought to myself, there is no way that some little old Chinese dude with a beard down to his knees just sat down and drew it in the sand and thought, wow, this is something cool. This symbol is really neat. I started pulling it apart in my mind and I thought, what would that have been if it was technology? I don't want to go down the ancient aliens and conspiracy theory rabbit holes, but I'm a firm believer that we are not the first ones here on this planet. I was thinking if some old dude somewhere was staring up at this piece of technology, what would he have been looking at? And my belief is that that yin and yang symbol was something he drew because he was seeing something literally right in front of him. So I think basically he was looking up at, I realized it could function as a wind turbine if it was totally closed, if it was furled, as I call it. And if you'd open that up, you have basically Harmony. If you're looking at Harmony from the top down or the bottom up, it is a yin and yang symbol when it's totally closed. And when you open it, that's the profile of it is a wind turbine. So that's where the idea came from. That's where I got the idea. The yin and yang symbol defines Harmony. It speaks to Harmony. So it was 4 or 5 different ways that Harmony was the perfect name for our company, for our product.
Sure. So since we're an audio podcast, if you could describe the picture of what this looks like, what the construction is current, maybe in the early stages and current stages, and then we'll be sure to put a link to your website so people can actually see real photographs of it and videos, because I know you have a YouTube channel too.
Harmony is what people would refer to as a modified Savonius vertical axis wind turbine. And by that very simple definition, a Savonius turbine, take a 55-gallon drum or a cylinder, slice it in half down the middle. So you now have 2 halves. And if you offset those halves from each other, that is a Savonius turbine. So you take a 55-gallon drum, take a laser beam, cut it straight down through the middle from top to bottom. Now separate those 2 halves by almost 2 feet from each other, and you've got...
Stack them vertically.
Not vertically stacked, but move one horizontally to the other. So you have your 55-gallon drum, and you move the one away from the other.
So you create a place for the wind to sneak in.
Correct.
It's kind of like 2 cups, but they're in opposite directions so that it can rotate.
But slid.
Yes, you slide them left to right, or if you, speaking in Cartesian coordinates in the x-axis, you slide the one cup away from the other in the x-axis. Now you have a Savonius turbine. Harmony is that design, but then we add a helix twist to it. So it's a complete helix twist, which gives us 360 degrees of rotation and no interrupted cavitation or thumping that would occur. In a wind situation, when you have a dead spot or an inability for it to rotate because it's at a funky angle, you see that on a scope of whatever you're monitoring the rotations with, you would actually see that thumping or that bumping each time it went around. By having a full helix on Harmony, we eliminate that. There's no angle that it can be at that you're not catching the wind.
So the helix comes by virtue of the stacking effect of those points of interception. So no matter it's stationary, vertical, the wind is blowing from a direction most of the time, but any direction the wind blows, it's going to hit the scoop.
Correct. We call them scoops. Yep. So that Savonius turbine, the 55-gallon drum, is basically what Harmony is. We just cut it down shorter and made smaller segments. So instead of it being 4 feet tall, 1 scoop, now we have 4 scoops that are 1.5 feet tall. And the total overall height is about 5 feet tall and about 4 feet wide.
When
so
the scoops are
when it's fully opened,
right.
When it's fully unfurled.
You mentioned before briefly they furl. So what's the purpose of furling?
When you go out on YouTube and you start looking at all these big, huge, even the multi-million dollar wind turbines, there's all kinds of videos of these things catching on fire and blowing up and being destroyed in high wind situations. Because even the big boys out there, yes, they can feather their turbine blades, which helps them to capture different wind speeds a little bit better, but they cannot escape the wind. They can't get away from the wind. They can't retract those blades. Harmony can retract its blades. Harmony pulls its scoops in, which is what I call furling. So if you take the yin and yang symbol and you look at it from the top down, that is what Harmony looks like if you're looking at it from the top down when it's totally closed. So all you do to open it is rotate on those two, I don't know what you call them in the yin and yang symbol, those eyeballs, those center dots. If you rotate on those dots, counter from each other, you open back up into the wind turbine shape that we have. So that's why the yin and yang symbol was quite literally the birth of Harmony Turbines. It was where when I said, what would this symbol have been if it was actual technology? That's what came to my mind. I said, it's a wind turbine. So the purpose of that furling is to then protect it in high wind situations. We don't have to close up completely. Everyone's like, well, that's stupid. Why would you close up in the high winds? And we don't close up completely. We just close up maybe 10%, 20%, 30% to reduce our exposure to the wind. Now, at that point, we're doing something that no other wind turbine on the planet has a capability of doing. We have the ability to self-regulate our RPMs by how much exposure to the wind we have. And we do it without a dump load. We do it without a braking system. We don't have any crazy apparatus in here to manage an overspeed situation other than the inherent operation of Harmony itself. It simply furls in 10% or 20%, monitors its RPMs. I don't know if in your HVAC industry, if you have things called a PID loop, basically a constant loop that you're running saying, what temperature do I need to be at? How much do I need to cool to get there? Have I achieved it? And then it does that same loop over and over again, thousands of times a day.
Thank you for correlating to our industry. That was great.
Yes, absolutely. We use those in temperature control and all kinds of other control systems around in.
We do it in Harmony. We say, what is our safe RPM range for this model of turbine that we have? And as we start getting close to that, we pull in a little bit. And that PID loop runs in another 30 seconds or so. And it says if it needs to pull in more, it goes ahead and pulls in a little bit more. But it's able to self-regulate its speed through that very simple loop that will constantly run to open and close the scoops appropriately to the wind conditions.
And the idea is that he mentioned earlier that when it's fully closed, it has the yin-yang symbol from the top, but normal operation shouldn't have it fully closed. If you have a really big storm, you would still find it open a little bit. It's still capturing wind. It's still producing power. It's just as protected as it can be and as it needs to be. But it would probably never really be closed unless you close it in an emergency situation.
Or a maintenance situation.
Maintenance.
You want to shut it down and grease the bearings or something like that. So in those cases, you would fully close it.
It's like a sailboat to me. When you get really high wind, you make the sails smaller so that you don't knock the boat over.
And Eric, what is that called in sailing?
Furling, exactly.
There you go.
My brain went right to that. So I'm curious, my brain immediately is rolling around this and thinking about this process because that's what I do. And I'm curious about how you handle high sudden wind gusts because we know we get those periodically. This is fascinating to me.
In nature, okay, you have to separate your statement about high wind gusts fall into two categories. One is nature created gusts, and the other is a bomb just dropped a mile away. Okay, we can't protect you against a bomb that just dropped a mile away, and you got hit with 100-mile-an-hour wind in literally a split second. It's not possible.
And you got other problems.
Yeah, you've got a little bit more of an issue there than your wind turbine fell over.
Way bigger problems than my wind turbine just overspun.
We don't even bother with that one, Eric. It's just not on the table. Nature is a little bit different. I know you think that, suddenly this gust came up out of nowhere, but it's not like out in the ocean, a rogue wave or something like that. Nature, when it begins getting gusty, it's a very slow progression. You begin getting gusty in an amount of time that can be, from a wind turbine standpoint, it would be minutes. That's forever. When you're talking, we can go from fully open to fully closed in 30 seconds. Basically, we can handle that situation. As soon as it would start seeing that gusting wind and those conditions starting to rotate beyond the safe limits, it would immediately begin pulling in. So you'd be pulling in as that wind is coming up. I don't know of any situation in nature where you would go from 0 to 60-mile-an-hour winds in under a 5 or 10 minute period. It just doesn't happen. There's situational things around you that are causing it to, okay, A tornado. There we go. That would probably fall into the same category as a bomb. You've got other problems if a tornado.
You got way bigger problems at that point.
Emergencies.
Other than a tornado, which, yeah, people ask us that. Well, is this going to survive tornadoes? No. Come on.
Neither is your house.
Yeah. I'm not saying it won't happen in a few cases that the Harmony will be sitting there and everything else around it will be destroyed. I'm sure it'll happen. It'll be pretty, well, that I shouldn't say it'll be cool to see that, but it'd be horrible to see it, but fascinating at the same time.
How fast realistically can this handle as far as RPM speed?
The models that we're working on, and keep in mind, the model that we're working on is just a very first early product that we're introducing. Just like Henry Ford had to come out with his first Model T car, but he made many other models after that. And this is our first initial product that we're releasing to the public. So the initial product is going to be somewhere in the 500 watt range. It'll be probably around 200 RPMs in a 25 mile an hour wind. So every wind turbine out there is rated in wind speeds usually ranging from 24 to 30 miles an hour because there's just no power in the wind below that range. So no wind turbine company out there bothers to rate their wind turbines in a 10 mile an hour wind. It just doesn't make sense. What people need to keep in mind is just because that wind turbine is rated in a 25 mile an hour wind doesn't mean you, Eric, and you, Bill, are going to get 25 mile an hour winds at your home on a regular basis. You may get them on occasion, but that's the difference. Where Harmony is rated at a 500 watt output in 25 mile an hours and spinning at 200 RPMs, our hope with our design is that we are capturing wind at a much lower range more efficiently than any other turbine out there because Savonius turbines are the king of low wind speed capture. When you look at all the turbines out there on the market, Savonius has gotten a really bad rap over the years because of some bad information that was published. It's all on our FAQ on our website about this erroneous information that was put out in the 50s. They actually misdrew some lines from where the Savonius turbine was doing its performance versus the good old-fashioned farm windmill. They actually misdrew the two lines. And there's theories out there that that wasn't an accident. It was done by someone who was paid in the industry to misrepresent some information. It created a 50-year, what do we want to say, a situation for 50 years where Savonius turbines were literally ignored and people looked at them as the redheaded stepchild of wind turbines. When in reality, we're hoping and helping to change this paradigm. We're looking to actually correct the history books, so to speak, and say, look, Savonius turbines are amazing in these conditions, and let's capitalize on what those strengths are, which is low wind speed capture. So if we can capture wind speeds in the 8 to 16 mile an hour range and be more efficient than other turbines out there on the market, now you've got something to really stand up and take notice of. Yes, it's not going to be magic. It's not going to be creating free energy here. It needs the wind to make electricity. But if we can capture it more efficiently than other turbines do at lower wind speeds, now we've got a corner of the market that no one else can capitalize on. And on top of that, when the wind conditions get rough, now we have the ability, again, that no one else has to protect ourselves that the other wind turbines don't.
And while protecting ourselves, we're still producing energy when they're not.
The other wind turbines out there, the propeller turbines, they actually have to stop spinning. They put this crazy braking mechanism on and stop spinning in the high winds. We were down at the shore a couple years ago and I took video footage of it. The thing was on top of a boat on like a 30-foot pole on this sailboat, and it was frenetic. It was crazy. It was sitting there like, and then it would stop. And then it would stop again. It was doing this over and over and over and over. That's how that wind turbine was dealing with the high wind situation, because it was right at its cut in, cut out point. And Harmony would simply be closed up, maybe 10, 20, 30%, whatever, and it would be spinning happily through that entire event. It'd be producing normal power. It wouldn't be on, off, and making all this crazy noise and doing all these frenetic, crazy motions and movements. It would just be spinning properly in that wind speed because it just pulls in and furls.
So then what's the maximum wind speed you can handle then?
We don't know yet. That's the cool part about R&D.
Yeah, so just a disclaimer of the things that we've already talked about, the numbers that he's talking about, we're still in testing, and we haven't published data yet because we're not done testing.
No, we're not done development.
So
I'll stop asking these detailed questions then.
You're allowed to because other people have them. That means it's okay for you to ask. The big hang up has been finding a generator that can be tuned to the correct RPM range that we need. So you're in the industry dealing with motors all the time. You probably don't get into generators very often, but a motor and a generator are essentially the same thing. You're either putting power into the coils and driving that shaft, or you're putting power into the shaft and generating power at the coils. We have a situation with Harmony. You heard me say 200 RPM in a 25 mile an hour wind. So that means, let's just, for kicks and giggles, say 300 RPM is our max safe range for Harmony at this model turbine. What generator do you know of out there in the market that runs at 300 RPM?
Not any that I'm aware of.
There are none that I know
of. So you have to make something.
300 RPM is absurd. Everything out there is like 6,000 RPM, 9,000 RPM, 1,800 RPM, 3,600 RPM, 7,200 RPM. Heck, even your alternator on your car is like 6,000 RPM before it cuts in and things like that. There are so many generators out there that are purpose-built for much, much higher RPM ranges that we have had a very difficult time finding a generator that can work natively in the RPM range we need. And everyone's like, well, that's simple. Just gear it up. Okay, smart guy. That's what I have to say to these people, these trolls. Hop on your 10-speed bike, put it in 10th gear, and go find a hill that has just a half a degree grade uphill. Not even what you would call a hill, just the slightest uphill grade. Hop on that 10-speed bike in 10th gear and try and start pedaling. It doesn't work. Now, we're not in 10th gear because 10 to 1 would only be 2,000 RPM. We have to be in like 30th gear. So this is the challenge. So we have a very, very low RPM range. We can't sit there and gear it up because then you put so much starting torque on the turbine that you can't even begin spinning in low wind speeds. See, wind is unique. I'll digress a tiny bit and give a little dissertation on why wind is unique here. When you have a diesel turbine, when you have a diesel generator, a gasoline generator, a hydro turbine, any of these things, steam turbines, they have a huge amount of incoming torque. They have massive amounts of power behind them. So they don't care about the startup torque. They don't care about getting that motive force spinning initially because they've got all the power on the back end that they need to get that rotational system moving. Wind is unique. Wind starts with nothing, literally nothing, and builds very slowly from there. You put any type of a turbine, even in water or anything like that, water is 1,000 times thicker than air. It has so much more torque. It's unbelievable. But air is unique. Air is the only thing that I can think of that literally starts with no torque at all, and you need to begin there. So we have to deal with that situation. We have to be able to have our turbine start with a zero torque situation and begin spinning, begin getting all that inertia, all that mass moving, so that when the higher winds are coming, you're already spinning.
So that plays into your tuning of this as well. Like you've got to play into, because I'm looking on the website here at harmonyturbines.com, and I'm seeing a mention of something like an air gap on your generator, which again, very intriguing to me because that changes the amount of magnetic force that you're going to transfer in that.
Eric, you must be an engineer by trade.
No, not at all. I'm a tinkerer.
I know Bill said he was an engineer.
Mm-hmm.
Yes. So Harmony has 2 patents under its umbrella. And when I conceived of the wind turbine, I not only conceived of the wind turbine, but then I also built what I believe to be the perfect system for capturing that energy with a generator of our own design. So you're absolutely right. Under the covers of our patent, I have 2 different protections. One is the furling system and how that all plays out. The other is our variable air gap generator. So we have an axial flux, dual pole excitation. That means north and south being excited at the same time, axial flux generator with the very first of its kind, never before patented, variable air gap. We have had NASA contact us. We have had Lawrence Livermore National Laboratories contact us. We've had some really, now I won't say NASA officially. It was like retired NASA engineers and things like that. So apologies there. It's not like NASA officially called us and the phone said, NASA is calling you. The contacts from Lawrence Livermore were actual contacts from Lawrence Livermore reaching out. And for anyone who knows, they are the pinnacle of energy research in the United States. Los Alamos and Lawrence Livermore are where the buck stops. They are the peak of where energy research in the US goes. Fusion research, fission research, all kinds of incredible things. And they were reaching out to a little tiny company like Harmony Turbines. It was pretty interesting, I'll say that. So that whole generator that you're looking at there, Eric, and you're saying, wow, that's fascinating with a variable air gap. It allows us to do solid core coils, which is higher power density once we're moving, once we're spinning, north and south pole being excited at the same time. So the same motive force going into it is now giving you double the bang for the buck because you're hitting the north and south pole of that coil at the same time. But you're starting with zero cogging or zero startup reluctance because you can begin with those magnets far away from the coils. We are the first to ever patent anything like that. And it's pretty freaking incredible when you think about it. But that path to develop that is a long time. There's a lot that goes into that. That mechanism is not simple to do. Now, we've made huge leaps in that development, but here's the problem. I don't want to sit here and hold up the wind turbine development for another 2 years, 3 years to finally perfect our generator. And then in the end, when we do that, we might find that it's just too expensive to sell it practically to people in the residential market. We might push the price up to a point where it's just not practical for people to buy. So I don't want to encumber Harmony with that extra R&D, with those extra costs, with that extra time and all that, only to find out in the end, crap, it's going to be too high priced. It's not worth it.
You definitely want to make sure the juice is worth the breeze.
Yeah. Yes. I like that.
Bill's a punny guy.
You're seeing the conundrum here. You're seeing the little bit of the history unfolding of where we're at. Yes, we have some amazing technology under the covers, but we've got one big problem facing us right now. The turbine development is so rock solid. We're so happy with where this is at, where our kit development is, where the furling system and all of the, if you watch our latest video, we've got tons of footage in there of machining the components and everything. It is, I'm giddy like a schoolgirl when I think about how well Mark III went together and how well the components fit together, the tolerances, the assembly, the ease of assembly, everything. But the damn generator is the problem. We need to find a generator that we can just pull off the shelf or get from some manufacturer somewhere to work with our turbines right now, because we could get out in beta testing and be out in the market if we had this right now. I don't want to sit there and wait another X number of years to finish our generator development. That's a whole separate ballgame, and we're probably going to go down that path in a few years to market that literally to other wind turbine manufacturers, because that generator could be bolted on to any wind turbine out there in the market. Even the big multi-million-dollar turbines right now need to have a kicker motor to start them. People don't realize that. They can't get started on their own. Back in the day, they used to use like a 50 horsepower Kubota diesel engine, and the thing would be like, people would look up and be like, why does that wind turbine sound like a motor running? Because it was a Kubota diesel engine getting the doggone thing started, getting it spinning, just so that then when the wind was at the right speed, they could cut that motor off and let the wind take over.
So are they using a separate motor to start those, or are they using a back feed into the generator to start that up?
The newer models now have the ability to use electronic starting. They're all tied to the grid anyway, so they're just pulling power from the grid to get started. I don't know whether it's a separate kicker motor or whether I doubt that they're running the generator in reverse. That generator is purpose built for creating power. I don't know that they're running it in reverse, so they probably just have, just like your car, it's got a little starter motor on the side of it. It ties into the very large spur gear, and they can get it started that way.
That's fascinating. I never even considered that.
Yep. But with our generator, you literally wouldn't need any of that. And you would have the ability to be self-regulating in many ways. Like the job that a charge controller does, a lot of people that get into wind turbines and even solar, they have what's called a charge controller on their system. With our generator, it may eliminate or largely reduce the need for an intelligent charge controller, because you can just vary the distance of that air gap of those coils and magnets, and now you're regulating your power in a way that was never able to be regulated before.
Yeah, and combining the regulation of the air gap plus the regulation of the furling, it becomes a lot more complicated from a control standpoint. But there again, my brain is going, wow, okay, there's a lot more possibility there. I'm just curious, are these generators, I don't know much about generators, haven't really played around with them much. Are these all permanent magnets in the generators? Okay, so they're not a rotationally induced magnetic field.
Correct. We are looking at, in fact, we were toying with a company that wanted us to come down and visit with them and work with them. They had ideas for doing pretty much what a car alternator does. And without varying the air gap, they were looking to do, you would call it variable reluctance generator. So they were looking to push a low amount of voltage into the coils initially, into the primary coils, which would then vary what's coming out of your secondary. That hasn't really gone anywhere to date. They got pulled away on another project, so we never went down to visit with them. But I'm not a generator company. I don't have hundreds of people working for me that we can work on this stuff. So we have to be very careful about what we work on with our tiny little crew. And even though we have the technology patented and the ability to move forward with a very exciting design here with our generators and with our turbines, you have to look at what's the fastest way we can get to market. So what I would say is the back end potential of these are huge. When you said you're sitting there and your mind is blown a little bit as you think about all this, I have that every single day. I think, my God, this could go so far, so fast if we had the right connections, if we had the right partners, if we had the right groups with us and backing us and working with us. The universe has to help that along. You can't just pop up in the middle of a cornfield somewhere and have this amazing technology happen. It's a synergy of events. You've got to have synchronicity between people like yourselves. Someone on your podcast hears about it and they're like, oh my God, our company works with this group that does exactly what Harmony needs. And suddenly these things gel and they fit together. That has to happen for the big picture to really take place, because you may have all of this amazing technology patented and the ability to develop it is just, those pieces need to also come along for the ride. You need to have the right partners or the right groups to work with, because it would take you, God, I don't know how long it would take for us to develop every single one of these things by ourselves from the ground up. It'd be nice to tap into groups that already have the ability to help us and say, oh man, we've been working with axial flux generators or motors for a long time. It'd be nothing to switch over to doing generators and save us 4 years of development. But we'll see how this stuff plays out.
Axial flux motors in the motor market are new.
They're a big thing now, more ever than before. In the last 2 years, you're hearing axial flux motors all over the place. Eric, you're absolutely right. We're the first axial flux generator to have a patented variable air gap. And not only that, but we have the system to do it. We have the ability. It's in our shop right now. It works.
It's covered with a trash bag.
Yeah.
So nobody can see it when they visit. So it's not in my pictures when I take pictures.
That's our top secret room is right. Literally we have to cover it with a trash bag when people come to visit, because it is the secret sauce stuff. How you do that is not a simple thing. And it's fascinating. When I drew up the plans for doing the very first one, I literally took 2 years to figure out how to even get it to do what it does. And then after we made the first one, I was like, oh my God, we could do this so much easier if we tried this. And then we're now on the Mark III with our generator. I keep having these epiphanies or these flashes of inspiration, so to speak, of how we can make it more stable, more rigid. And each time it's a leap forward in exactly what you want with development. You're making huge improvements, but how much do you delay the overall project to perfect this thing that could take a few years to get it really off the ground properly?
Do you work with any universities or programs like that?
We have, yes, and we do. But they have their own agenda. They have their own goals. They have their own things that they need to achieve or the end result that they need to write about. And when we began working with some of the universities, we thought, oh, this will be amazing. They're going to do all this wonderful work for us. But that didn't quite work out like we had hoped. We didn't get all the juicy data that we had hoped. Students are students. They procrastinate. They put things off. They only are in class like from 1 p.m. to 3 p.m. And well, darn, the wind wasn't blowing today. It blew all night. What do you mean you didn't pull an all-nighter to come out and...
They don't have quite the passion you might have.
Yeah. So we were so excited when we had 3 university partners that were on board with us initially, but 2 of them have already now finished their project and turned in their data. And in the end, it was only mildly helpful. I'm thankful to the universities for being interested in working with us. But when it comes down to it, it's not what we thought it was going to be. We thought we would be able to hand them this problem and they'd come back with all these solutions. Not even close.
I get it. We've done some stuff with students and I've mentored some students, but they can only go so far. It's a semester's worth. That's what you get.
It was underwhelming when it finally came down to it at the end. We were like, after all these months, after all the time and effort and money we put into doing that stuff, it was a learning curve. So as a small company, you have to learn all this stuff. No one sits there and tells you, don't bother with the universities. It's just a waste of time or this and that. No one's telling you these things when you start out as a new company.
So if I could explore a little bit, you're not in a basement, obviously. It looks better lit than that. And as much detail as you're comfortable sharing, what's the structure of your company? What's your location like? How many people working?
We currently have 6 full-time employees. We're in a 10,000 square foot facility. We have CNC equipment to the tune of 3 VMCs, which are vertical milling centers, and 1 5-axis, a mill turn lathe that enables us to make, between those 4 machines, pretty much every single part that we have for Harmony, both for our generator and for our turbine itself. So we can produce all of the 3D components that need to be machined. And we have a partner next door to us with his own, 25,000 square feet facility, 30,000 square feet. He has water jet, laser, rolling, crimping, and all of the other things that we would require for like the sheet metal on our scoops and things like that. So between his facility and our facility, we have over 99% of every component that we need to make for Harmony right here in-house. Now, we can't go into high volume production with that. We couldn't even go into medium volume production with that, but we can be in R&D and prototype stage and early beta testing and low volume production where we're making a few units a month and everything to get the concept out there.
You got to iterate, fail fast, that kind of concept.
Yeah.
What town are you in or what town are you near? Just people.
We're in Lebanon, Pennsylvania, near the Hershey-Harrisburg area. I was just going to comment with a little more information about our people, the structure of the company. So we have 6 people, like Chris said, but the people that we have on our team are very specific, and we've tried very carefully to only hire what we need on the team.
When we need it.
When we need it. So it started first with Chris, then I came on board. He's the jack of all trades and everything. I came on to help with administrative and operational things because that's my background, and that would free him up to work on development. And then we hired an engineer to help him with designing. And then we hired a shop assistant who helps keep everything run smoothly on the back end. He does, I guess, a lot of the dirty work, if you would say that. He's amazing. And then we hired a machinist to help with machining because Chris and him work on all the machines there and crank out the pieces. And we recently hired an office manager who she and I together work on all the social media, the bookkeeping, everything administrative. So we each have our own specialties. Everyone was hired for a specific purpose. The team is really great.
Yeah, it is awesome.
We really have a great group.
We are actually just yesterday or 2 days ago posted our 7th position. And that is something we literally just identified because of all the problems we're having with finding the right generator. And we just posted a position for an electronics engineer, not an electrical engineer, but someone to work with microelectronics and circuit boards, PCBs, just the ins and outs of the difficulties we're having with our generator this position will greatly enhance our abilities if we have someone who's got the right mix of skill set in there. That I'm hoping we can find someone that's really well versed with building microelectronics and small electronics from the ground up and understands resistance and power conversion and AC, DC. I have these skills to a very small degree, but I would like to have someone in here with 10 to 15 years of expertise in this that could really be like, oh man, we could totally make an analog system to do this same thing that these stupid charge controllers are doing in an electronic way with hard set points. We can do it with a very simple analog system if we do this, and allow us to maybe ramp our power production curve in more smoothly. But we identified that need probably a few months later than we should have. It was, you never can see the forest for the trees when you're at the ground level working on this stuff. So having this person here now will really help us to move forward, I think, with the part we're stuck on, which is, quite frankly, finding the right generator to work with our turbine right now. So we've got a few generators off the shelf that appear to be spec'd correctly, where in a 200 RPM range, they're putting out 500 watts of power, but that power curve is so dense and so small that what we're finding is the charge controllers that are out there, when they say, okay, at 8 volts, allow, the very first step is at 8 volts or 6 volts, allow 2 amps to flow. Well, suddenly that's like hitting a brick wall. It's not smooth enough. So the charge controllers, now we've found potentially a generator or two that will work with our turbine, but now we're running into the charge controllers, the problem. So we're like, oh, dear God. So this is why we're looking for an electronics engineer right now to really help with this final piece so that we could get these units out and start beginning with alpha and beta testing in the field.
Should one of our listeners have a question or maybe an insight to share, can we share your email address?
Of course.
Yeah, the best one is support@harmonyturbines.com. And that comes to Hannah and myself, and we answer what we can and we pass along the other emails.
Yeah.
We have a lot of tinkerers in our sphere.
From the old James Bond movies, I think Q was the guy's name. I'd love to hire a person like him, Q. Or if you're a fan of the Netflix series, The 100, there's a girl in there named Raven. I'd love to, I joke around saying I want to hire Raven. But we need someone who can take a walkie-talkie, a microwave oven, and a toaster and cobble those together to make a charge controller. And when I get the person in for the interview that is able to say, oh yeah, that's no problem, that's the person we're hiring.
Yeah. Bring your science project with you.
Basically, I've tinkered with that stuff for years, but I've never dedicated a lot of time to it. So I don't have the expertise nor the time to learn that area, but they're out there. They exist. They do live in our area. We just need to find the right person.
So as we wrap up here, what closing thoughts would you like to leave our listeners with?
The one main thing that we'd like to emphasize is simply that we are still in research. We are still in the R&D phase. We're not in production. Probably the biggest thing people get upset about is that we're not yet in production. And some people say, we've been at this so long. Really, we haven't. It was in my basement and in my garage for a number of years. We only began in earnest in the summer of 22, when we really began with the current versions and the current prototypes that we have and looking at marketing this reliably out to the public. So we've been at it for about 2 years with the current prototype development. So I would ask for a little grace or forgiveness from our community, because we've been sharing this journey from day one. And so people look back at 3 and 4 year old videos, but that's stuff that's in my basement, and they get mad because it's not ready yet.
This stuff takes time, people. It is not an overnight.
It takes time and money to do this stuff.
Yeah, and money. It does take time and money.
And because you watched this and tracked it, doesn't mean you're entitled to anything.
Right.
Except to watch and track it more.
Yeah, because they just get mad because it's taking so long. But in a way, that's a good problem to have, because it means they want what we have and they're mad that it's not there and they can't just go click a button on Amazon and buy it. Well, we're working on it. We're doing our best to do good R&D, to do good work, to get these products out there, to not have another failed product on the market that's just a piece of crap. We want Harmony to be different. We would like it to be game changing, so that when people 10 years, 20 years from now look back and think about small wind turbines, Harmony is the de facto standard of that generation. It's like the smartphone that we're trying to develop in an era when there was nothing but bag phones and suitcase phones. That's what we're trying to do with Harmony.
Fascinating.
Very cool.
Yeah.
So many little things that looking at a picture on the internet just doesn't tell you.
Yeah.
So, Chris, Cheryl, how are you going about raising the funds to do all this important work?
Right now, we have our crowdfunding raise opened on Start Engine. So if people are interested in what we're doing, if they believe in what we're doing and want to help support or enable that movement, we would encourage them to simply go to our website. It's harmonyturbines.com. And they can just click the link that's right in front of them that says Invest Now. That'll take them to Start Engine. There's a number of questions that they have to go through if they've never invested before, but the minimum investment is $200. So you don't have to be rich to do this. In fact, we prefer having a lot of small investors, small supporters, rather than a couple big whales trying to tell us how to do things and how we should run our company. That's why we did it this way. I prefer to have many small supporters helping us with this journey rather than some bigwigs that think they own you then. So $200 minimum investment. They can go to harmonyturbines.com, click on Invest Now. There will be a bunch of annoying questions that they have to answer, but then they will receive their shares in the company and become part owner in the company for whatever Harmony Turbines has here in the future going for it. So I'd love to think that we have a beautifully bright future if we do things correctly, if we are able to pull this off and achieve what the technology that's been patented has underneath it, the promise that's there, and all of the things when you read between the lines that could happen if this goes right are just absolutely huge. That's the thing that makes it so exciting. When you look at it, you're like, wow, this is really, really different from any other product out there on the market. Yes, it's a wind turbine, but it's got some really unique features to it that do not exist elsewhere. And that's what's so exciting about our technology. At least I think so.
Fantastic.
Hopefully you guys do too.
We do. I think Eric's going to have something bugging him here for a while till he starts. So he'll probably be in touch too.
There's things rolling around in the back of my head.
Yeah.
We really want to thank you for coming on the podcast today. It's a little bit different, but as we spoke about before we started, Eric and I are both into energy monitoring. In fact, episode coming out, I think it might be the one that dropped today, Eric, that's about home energy monitoring madness. Is what it's called. Home monitoring madness, not just energy, but other things we measure in our homes. So Eric and I had a discussion about that. So we're into this stuff. We hope some of our listeners are, and we hope they reach out and at least learn more about what you're doing. And if so moved, to decide to make an investment through Start Engine. That'd be fantastic to help you achieve your goals.
Thank you.
Yeah.
Thank you very much. And we'll let our listeners get back to their things, but keep this in your mind. Harmony Wind Turbines.
Thank you.
Appreciate you listening to this episode of the Building HVAC Science Podcast, where we spoke with Chris and Cheryl Moore about reinventing wind power in their world of Harmony Turbines from Lebanon, PA. If you're in the market for any tools or test instruments mentioned in our podcast, take a look at what TruTech Tools, our company, offers, TruTechTools.com. You can use the offer code HVACBS for a nice discount. In full disclosure, I'm a co-owner of TruTech. And the opinions voiced are those of my guests, my co-host, or myself, depending on who is speaking, of course. The Building HVAC Science Podcast is a production of TruTech Tools Limited, and we love interfacing all those different trade-related resources, influencers out there, including HomeDiagnosis.tv, AC Service Tech, MeasureQuick, HVA Chicks, the misfits of HVAC, HVAC Our School, HVAC Shop Talk, Stephen Reardon, HVAC Reefer Guy, Tool Pros, Service Business Mastery, Quality HVAC, HVAC Overtime, and HVAC videos. Did I leave out HVAC Grapevine? It's still in there. Should still be in there. Sorry about that, guys. In any case, please listen to all these great trade-related resources. Some of them are on YouTube, some of them live stream, some of them also on podcast. It's a great world out there of learning and sharing experience, and we encourage you to do that. And until next time, We look forward to having you back to listen to another episode of the Building HVAC Science Podcast. Take care.